Hello everyone, welcome back to the course. So in the last video we gave our paddle some movement here. I'm going to show you. So if we move on the A or on the X axis by using A and D keys or the left and right arrows, we can move left and right, and we also made sure that our paddle doesn't go off the screen into infinity. It was a fairly short and sweet script, pretty simple, but for those of you who didn't get it, we're going to go into it in a little bit more detail in this video. So let's hop right to it. So coming over to our paddle script here, let's go ahead and save that, any changes that I made. So the first thing we did, and I think I said it in the last video, is anything in physics, and this is true for the real world, programming, anything, if it's going to move, it needs a speed. That's period, end of story. Technically anything on Earth is moving, but without getting into all that, if it's going to move, it needs a speed. And we just set so we made a variable here of type float, and named it move speed, and we set it to 15. So from there, without looking at any of this yet, we actually moved the object, and this is the line right here that actually moves our object. And what we did was we called our transform component, and you can actually see that on our paddle right here. In one of the videos I mentioned that every 3D object in Unity has a transform, and that is true for every 3D object in our scene, no matter what it is. This is the only component that will always exist on every object in your scene. And the transform has a position, a rotation, and a scale. So if we were going to move our object in world space, I feel like we would probably be using this position property right here. And we kind of do, but we're not directly accessing position because Unity provides a function that kind of does that for us. It does all the complex math to make it move without being jittery. At least for the most part. And that is actually called translate, and that is a function that resides on our transform component. So you just call transform dot translate, and translate moves our objects. Now, this is not the only absolute way to move an object in Unity, and in fact, transform dot translate in a real world 3D game is actually considered bad practice unless it's just a really small movement that you're just trying to get. But for our purposes, transform.translate is actually perfect. So if I were to look at the IntelliSense for transform.translate, there's actually 6 overloads, and we're actually using the first one. As you can see, we don't have any other parameters, although we're doing some, kind of not really, pretty complex map multiplication over here if you don't really understand it, but it's actually not very hard. And what we're doing is we're making a new vector3, and we're calling the input.getAxis horizontal. I think I explained this in another video, but just to reiterate here for anybody who maybe not have been paying attention. What we do is we call our input manager, which if we came here and went to edit, project settings, input, and it's going to open like this actually if you've never opened it before. And you can see our axes here, and we've got a few of them. But the one we're looking for is actually horizontal. And some of these have actually been duplicated. This horizontal right here is made for if you were using like an Xbox controller. So the one we really want is this horizontal right here, the first one. And you can see the negative button, so the one that would, give us -1 if we were to press it, would be left. And we know that moving an object, and let's just go ahead and come over here. I'll create a cube. I'll put it at 0, 0, 0 so we can all see it. And if I were to move this object -1 on the x-axis, you can see that it indeed does move left. And the same is true for moving right. If I were to do a positive translation, you could see that it does indeed move right. So that is that, and get rid of our cube here. Let's go back to the input manager. And that positive button is the right arrow key. Now, what most people use for moving in video games is W, A, S, and D. And so we have down here our alternative negative button, which would be A, which would move left, and the alternative positive button, which is D, which would move right. And that's what most people are pretty used to. The rest of these values in here we really don't have to care about, but we do have to make sure that this name is always going to be horizontal. Otherwise, if we change the name to anything else, we would have to come back here and change it in our code as well. From there, we're making sure that we're putting this input.getAxis horizontal on the x-axis, since we only want our paddle to ever move along the left and right x-axis. And then we will translate on the y-axis by 0, and obviously we will translate on the z-axis by 0. Now, the next thing I'm doing is I'm multiplying my input.getAxis, my vector 3 that I made, by move speed, which is 15. So, if I were to come in here and make a couple debug logs, first thing I want to debug is my horizontal axis from the input manager. I just want to see what that returns to me. Maybe the next thing I would want to debug is the vector 3 that I'm making here. So go ahead and debug this vector 3, and you can debug the vector 3, by the way. Well, make sure we make it an actual vector 3 there, and end our statement. So that will be the third thing that I debug. And then the last thing I want to debug is actually this vector 3 times my move speed. And just to show everyone what multiplying a vector by any number really does to that vector 3. Now, this is going to give us kind of a lot of inputs. What I like to do is just specify which debug this is going to be, and then this one would be vector 3, and then this one is just showing us what vector multiplication is all about. So let's go ahead and nope. Yeah, it likes to do this for whatever reason when I'm using Visual Studio. Let it think for a second. I don't know why it does that. It just kind of started doing that. It's never done it before. But anyway, so yeah, we'll start our game here. And you can see right now, if I start my console, and this is our brick instantiation. I should actually, just for the sake of it, I'll go back here. This is from our last video. And just go ahead and I will comment it out, just in case anybody wants to use it later. Okay, so from there, now we can go back. Let's start this up. And we can see, first of all, we're getting a ton of these. I have them at collapse, but if I wasn't, then it would just literally just go crazy. So right now, my input is 0. Let's pay attention to just input right now. So let's say I want to press D. That was so. Just want to press D here, and you can see I got a lot of input. Got a ton of input. Actually, let's go ahead and just restart this real quick. And I'm just going to press D for like a couple of seconds. Just like that. That's fine. And what you can see from here is just paying attention to this input. It starts at a really low number, kind of gets higher and higher and higher. It kind of lerps itself up all the way till when I get to, it looks like maybe it was, oh, that's probably when I was actually letting go of it. It looks like the biggest one we had is 0.24 maybe. Somewhere around there. But, so yeah, I'm going to just start this all over again, and I'm just going to go, just keep it held down there. And you can see that it goes all the way up to 1, and the highest it will ever be is 1, and you can see that it was at 1 for 44 frames. All the other ones were just like maybe 1 or 2 frames there, but it stayed at 1 for 44 frames. And so I mean, you know, that was pretty much that. So I'm going to go ahead and do now is let's look at our input with our vector 3, this one right here. So we're going to be looking at these two, and go ahead and just comment this one out for now, and we'll come back to it as soon as we're done looking at our input and the vector 3 together. So let's do that. Okay, I think we did enough. Pause it, and you can see that, let's see, our input is like 0.99 pretty much, or 0.099 rather, and our vector 3 is pretty much the exact same thing. It's at 0.1, so it's a just rounded up kind of version of this. And then we come here, it's 0.198. Vector 3 on the x-axis is, which is where we're using our input, would be 0.2, which is pretty much just this rounded up. And you can see, so, you know, we're moving at, you know, pretty much our input on the x-axis. And if I were to press A, it would pretty much just be this number, you know, times -1, or the negative version of this number. And we can go down here all the way up until our vector 3 is 1.0 and our input is 1, which is the maximum number it will ever be. But, of course, there are a couple of problems with just using this vector 3 for our movement. So let's go ahead and comment out this multiplication here. And we will come back to this. Start our game. Now, although 1 is a pretty small number, we have to keep in mind here that our playfield for this game starts at -10.5, give or take, and ends at 10.5. So the entire playfield is about 21 units long. Okay? Given that update is every frame, it's called every single frame, if we were to move by an input of 1 unit, which is what we do on our input.getAxis horizontal, if we were to move by a figure of 1 unit every frame, it would take about, you know, 21 or so frames to get all the way across this playfield. Given that a game is normally 60 frames per second, you can imagine it doesn't take too long to get all the way across this playfield. So the paddle's just way, way, way too fast here. The second problem with doing movement this way is that we want our game to be frame rate independent, meaning that in between updates, we actually have no idea, and in a small game like this, you can't really tell, but in between updates, we actually have no idea how much our object actually moved in between that frame. And yes, there is time in between frames, and that is actually called our time.delta time. I'm going to go ahead and just remove these, and I want to debug.log our time.delta time. So the time in between every frame, we're going to check that out. And you can see there's actually, pretty varying time in between some of our frames. It's seeming to, at least for me, sticking between like the 1.5, 1.8, or 0.015 to 0.018 area. That's pretty good, not too bad. But currently for our movement, update does not know what our object is doing in this small area of time, which in many cases is called lag. Kind of, I guess, it's not exactly, but I might get yelled at for saying that, but either way. So to counteract this frame rate independence problem, and not to mention the massive faster than light speeds we're traveling at, we are going to multiply our vector by time.delta time. And here I'm actually going to uncomment this, and I am going to, instead of move speed, we will just do time.delta time. Now let's see what we got. Oh yeah, now we're trucking. If you don't remember, time.delta time is an extremely small number, but we've solved at least one problem. Our game is now frame rate independent. So that's good. And as you can see, it's actually not even registering as a big enough number here. It's not even registering as a big enough number to even be put on to this debug log, so you didn't even really get to see anything. But believe me, there was a little bit of action going on there, at least, not much. So to solve this problem, very, very simple. We will come up here and we will create our own move speed, in which we will take this entire number that we just made and we will multiply it by our move speed, which is now 15. So while we're translating in this axis, why don't we go ahead and log our translation while we're at it. I'm just going to rename this to translation. Don't need this anymore. And should be good to go here. Oh, what's going on? Oh, I'm inside of a function. Need to close that. All right. Go away. There we go. And there we go. And we see we actually have a much more normalized, and it's still got a little bit of speed here, but not too much. And you can see that it's really constraining, obviously, between negative 0.3 and 0.3, which is good. We don't want to go all the way up to 1 because, as we saw earlier, that's almost faster than light. So, with all of that said, the only other problem that we were having, if you don't remember, come over here. Actually, I'll keep those so you guys can use them later. I will come up here and I will just comment out these two lines just so we can remember the other problem we were having. Well, we can just, kind of just go out into infinity. And, if you're a fan of not seeing, your player on the screen when you're playing a game, then by all means keep it this way. I, for one, like to be able to see what my player is doing, in this case, the paddle. So in order to fix that, we have these two lines here. I guess 4 lines of code, but 2 if statements, which is really the juice of the code. 1 to constrain our maximum x, and 1 to constrain us on our minimum x. So the first one is constraining us on our maximum x. And what it's saying is if our input.getAxis horizontal is greater than 0, so if we're moving right, if we are currently moving right, and our transform position.x, which we can actually see this in our component here, in our transform component, we have a position of x, and if we were to come over here, we see it moving, and it gets to about 12, and then, maybe a little bit, oh yeah, we haven't constrained it yet, but we see our position x moving here. If this transform position.x is greater than 12.7, then we're just going to return from this entire update function. We don't want to do anything else. We don't care about anything else because we have seen everything we need to see here. We're done. We're done with you. Go away. The same thing is going to be said for the inverse of this number, which would be the minimum x that our paddle is allowed to go. So if we are traveling left, so if input getAxis horizontal is less than 0, which means we're traveling left, and this transform position dot x is less than negative 12.7, get out of here. We don't need you anymore. We don't want to translate. Don't want to let our paddle translate anymore. So save this because I previously had it commented. And you can see this is actually working now. So we're pretty much creating a wall, if you will. And if you've never seen this in C#, the way that I have it, it's the if statement, and then right under it is my actual code for the statement. Without any braces. You can only do this if you have only one line of code under the if statement. If you want any more than one line of code in your if statement, then it has to be in the brackets. If it's only one line of code, then you can get away with just putting it under the if statement. I promise you, this is not Python. You need brackets. So what we will do, and make sure we do this before we return, say we bumped the right wall. We're making invisible walls here for our paddle to run into. So, and I just want you to see in the command line, or in the debug console rather, that this is working. So here, let our game kind of load. Over here in the left hand corner, you can kind of see where it's loading. Start it, and we will translate right, and we bump the right wall. You can see it down here, or if you want to go to the console, you can see it here too. And we bumped into him for 64 frames because I had the D key pressed the entire time. And now we've bumped the left wall 36 frames because I didn't press it for as long. And now we're good. We're constrained on our axes, and that is everything for paddle movements. That is probably the deepest dive I can give as far as translating and moving the paddle. So that's it for this. The next one we're going to get into is creating the ball. So I'll see you in the next video.